Transformation of sine function. Question 10. Determine maximum and minimum for y equals to minus 2 sine x in the domain 0 to 360 degrees. Right. Now, I will show you how to answer this kind of question in two different ways. Right. Let's do it graphically first. So let me sketch a graph here for the given function. So we are making a rough sketch which serves the purpose. So this is our sine function, right? So this is our sine function. So I'm drawing a sine function now, just sine x. Now we want to sketch y equals to minus 2 sine x. Now what does this mean? Minus means the graph gets reflected downwards, right? And 2 means stretched by a factor of 2. So initially we have a sine wave whose maximum and minimum is, maximum is plus 1 and the minimum is minus 1. Right? Now let's do the transformation in steps. So first one is minus, right? Minus means that gets reflected. So it gets reflected, so it becomes kind of like this. You see, it gets reflected on the x-axis, right? So this wave becomes like this, and then it goes up like this, and then reflected like this. So that is our reflected wave, which is, I should say, minus of sine x. Correct? So then we have taken care of minus part of it. Now let's do 2 times minus 2 times this. So 2 times means it gets vertically stretched. So this point is pulled. So instead of coming up to minus 1, this will now come up to minus 2. And on the positive side, it will be pulled upwards and will go to plus 2. Do you see that? So, but 0 remains at 0. So when you do that vertical stretch, your x-intercepts will not change. This is very important observation, right? You should make a note of this. Now, I'm doing a stretch and then my graph will look like this. You see? So this function which I've drawn now is actually minus 2 sine x, correct? Now from the graph, you can say what is the maximum and the minimum value. You will note that the maximum, minimum value, x values don't change. Do you see that? So if you see the function, we have 0 here, 360 degrees, one wave we have drawn, that is 180 degrees. The maximum was at 90 degrees. Earlier minimum was at 270 degrees. Now because of the reflection, maximum has become the minimum and minimum stretched and become maximum. Do you see that? So from the graph we can say maximum is at 270 and the value is plus 2, is 270 degrees and the value is plus 2, right? And the minimum is at 90 degrees, right? And the value is minus 2. So that happens to maximum and minimum. So this is how we can do it with the help of a graph. Now let me show you with the help of transformation. So whenever we do the transformation, the points get transformed. And we will see how do they get transformed, right? Let me make one table of values for the original function y equals to sine x and the other for y equals to minus 2 sine x. This is for y equals to minus 2 sine x, right? Now, initially, let's consider this orange graph y equals to sine x. So we have the coordinate points at 0, we have 0. 90 degrees, we have 1. 180 degrees, 0. 270 degrees, minus 1. And at 360 degrees, we have 0. Now the transformation is something like this. Original points are x and y. Now here, the x, y points do not change, but the y points get changed. So x points remain x. But what happens to y points? They get multiplied by minus 2. So they become minus 2 of original y points. So let's transform these points and see what happens. So x remains x. So let me write x points at 0. and the y becomes minus 2 times 0, which is still 0, right? Now for 90 degrees, at x equals to 90 degrees, minus 2 times 1 gives me minus 2. For 180 degrees, because x values are not changing, 0 becomes 0, correct? For 270 degrees, minus 1 times minus 2 gives me plus 2. And at 360 degrees, 0 times minus 2 is still 0, right? So what we observe here is that the maximum value is 2 for us and the minimum is minus 2, correct? So that becomes the maximum. And this becomes minimum. Do you see that? So basically we have two major transformations here. One, we should write reflection on x-axis, and second is vertical stretch by factor of 2, right? Now because of the reflection, maximum becomes minimum and minimum becomes maximum, and because of vertical stretch, their magnitude gets multiplied by 2. So instead of 1 and minus 1, we have the values 2 and minus 2, and the positions are changed. Instead of having maximum at 90 degrees, we have minimum at 90 degrees and maximum at 270 degrees for our transformed function y equals to minus 2 sine x. I hope that makes things absolutely clear for you and helps you to understand the transform functions. Great. Good luck and move on. Thank you.